Welcome to another episode of Threat Hunting series where we'll talk about threat hunting, incident response, malware analysis, and so much more. My name is Amr Thabit. I'm the founder of Maltrack, and today we're going to talk about how you can build your own threat hunting lab or purple team lab on AWS, on the cloud. If you're asking, so why do I need to build a threat hunting lab? What is threat hunting? What's the difference between threat hunting and purple team? Well, threat hunting is basically, rather than you are searching for an attack through its own hashes or domains that change from one attack to another, you're searching for a specific technique that happened in your organization. Mostly, in most of companies, you're sitting there waiting for an alert to happen from one of your IDS, IPS, EDR, antivirus. You're looking for something to happen, something detected by the tool. If it happened, then you go and investigate further. And if it doesn't happen, well, you just not knowing anything. If the attacker is able to bypass these technologies, you will never know, and the attacker can stay months and even years inside the organization, and you're just sitting there not knowing anything. Threat hunting basically look at this attacker profile. What are the techniques, the tactics he's using, and how I can investigate these attacks and hunt basically for them inside my log. See if these techniques has been used in my organization and bypassed my normal technologies. This is what threat hunting is about. Purple teaming is very similar in this way, but rather than you are hunting for them, you simulate these attacks in a kind of a lab environment, not your production environment, of course. In a lab environment, you simulate this attack and then look at the logs and see how this attack look like in the logs, if your tools are able to detect them or not. And if they are not, you create a new detection rule, you create a new alert that can help you detect these attacks in the future. There's so much of similarities here, but the purple team has the idea of simulating this attack as well. So what we're going to build now, we're going to build a lab in AWS that includes three different subnets. One is this lab, including a domain controller and a Windows 10 machine, and this is creates kind of a small company in a lab. You will have the attacker machines, you have the attacker network, where he has a command control server. It's an open source command control server called Caldera, which we will be using to send our malware, communicate with our backdoor, execute different commands, escalate privilege, maintain resistance, do whatever we want on this lab machine, basically simulating the attack we want to simulate. That will be our red team subnet, and our blue team subnet is basically a subnet where it gets all the logs from this lab, gets the Sysmon logs. We'll be using Sysmon, WinLogBeat, and Elasticsearch at the end to monitor for all the activities happening on that system. We'll be using the threat hunting ELK or threat hunting Elasticsearch and Elastic Stack, and that will be on our blue team. So this is basically the setup of our lab. Let me share the screen with you, and let's go into the setup of this lab and build it together in AWS. So what we're going to be using this time is the Purple Team Cloud Lab. It's an open source project I have created inside Maltrack. It's a cloud-based threat hunting purple teaming lab, and as I described to you, it includes three subnets. One is a kind of a simulation of a company. It's a domain controller and a Windows 10 machine. That is one subnet, and the second subnet is the blue team, which includes the threat hunting Elasticsearch. This threat hunting Elasticsearch basically collects all the logs from these two machines and saves it all inside Elasticsearch, and you can search through it. You can also use PowerShell remoting to connect to this machine. You can use Cape, Kanza, and so many different incident response and digital forensics frameworks, different tools as well. All of these tools are installed up here, and as well you include volatility if you take a memory dump, and you can use it from inside this machine. And the last machine and the last subnet is the Red Team Caldera. This is the attacker machine. This is the attacker subnet where he gets to attack these two machines, install a malware, send commands, escalate privileges, move laterally between these two machines, and take over the whole domain. It's an open source project as well that basically it's a command control server with 4 or 5 different malware, different backdoors that you can use. They have different way of communication, and there's so many commands you can use: Windows, Linux, Mac, whatever you want. So this is the three subnets. All of that is inside what's called a virtual private cloud. This is in AWS. It's a container for all your companies, so all your assets, all your resources, all your machines, subnets, everything. It's like a complete company, and you can expose this whole company to the internet or decide not to. So here we decided to make it public to the internet, and we had a VPC gateway, which is a gateway to the whole internet, and this is basically all our setup. So how we can install, how we can use this Purple Team Cloud app, this is what we're gonna see. So the first thing we're gonna do is to download that project up here. Once you unzip it and you have it, it will be in a folder called Purple Team Cloud Lab, and you will have some files like this. You have the main.tf. This is a Terraform project. What is Terraform? Terraform is a infrastructure as a code language. So for basically developers, they always automate all the code. They write a lot of code that automate a lot of things, but they never had the ability to automate building an infrastructure, like building virtual machines, installing Windows, installing Linux, connecting routers and setting firewall rules and all of these different things. And with the cloud, with all the abilities that cloud gives you, you can build so many machines and connect like really, really complex applications. You can use like functions that get spawned at some point, and Docker images, and all of them connected to other virtual machines or connected to a database, and you can build all of that as a production company, and then you have a production version, and you have the test version or the development version, and then you have a stage 1 and stage 2, and you can have multiple databases, and you can have a lot of different things. And to automate building all of this, they needed to create a language that is just designed to build the infrastructure, just designed to build the machines, connect them into a subnet, and create the virtual private cloud or the virtual company, create the gateways, and have all the firewall rules and all of that. We're gonna dive into the code soon, but first, let's see how we can build that project first. To build that project, you need two main applications. The first one is the AWS CLI. Basically, it's an Amazon tool that allows you to use AWS. All you're gonna need to do is to go to their website, download this AWS CLI wherever you are, on Windows or Mac or Linux. I recommend you to use Windows for that project. You really need to use Windows, and we're gonna see why, because you're gonna run some PowerShell commands that require PowerShell remoting, and they might not run easily on Mac or Linux. And once you install it, you should be able, when you open a terminal, to write basically AWS, and there will be some help here, some results. If it's not installed, you need to restart your machine, or reopen your terminal, or reinstall AWS until you make it run. The second one is Terraform. Terraform, as we said, is the language we are using, so it's really, really important to download it. And you go to download up here and download that tool. Once you download it, you have the Mac, Windows version, and basically it comes like if you download that file, so it will look like this, terraform.exe. Just take that file and copy it, and then go to your C Windows, for example, and you can paste it up here if you want, and that will be accessible through everything. As well, if you go back to the command line or of the Windows terminal, you should write Terraform and see some results, right? So what you're gonna do, the first thing you're gonna need to do is to go to your AWS account and create a user. This is very, very important. You need to create a user that will basically be controlled by Terraform. Let's do that step by step together. So this is the AWS interface, and the first thing, make sure that you choose Ireland up here, which is EU West 1, and I will tell you why in this video, at the end of the video. From here, I want you to search for IAM. That is very, very important. So go to IAM from here, and from there, I want you to create your own user. So go to users, and then add a user. And here you're gonna add the user you want. Let's say Terraform test 1, for example. And then click next. Okay, Terraform test, let's say. and click next. And now I want you to choose a specific policy. This user has to be an administrator on your machine. So click attach policies directly and then choose administrator access. That means that this user is an administrator user, so Terraform can use that user to be able to create all the machines for you. So you're gonna choose that one and then click next and then create the user. Once you created the user, once it's there, you need to create some credentials to access that user. So if we go back to that Terraform test we have created, you need to create some type of credentials. You go to security credentials, and from here, create something called access key. Access key is basically a kind of a two passwords basically that you can reuse to put it inside Terraform or inside AWS to be used from inside your machine and to be able to programmatically access that account. So create access key. We want the command line interface. It will be used by Terraform, and Terraform will be using your AWS command line application, AWS that we used in the Terraform in the terminal, and that AWS will be using that account to access your machine. So I want the command line interface and click next, and then you can write any information, and then it will gonna create a user for you. Before we go into that, we need to go here and write AWS configure. And once you write that, it will ask you to put an access key. And once you create up here, it will create an access key and as well a secret key. And you're gonna paste these two keys up here. So you're gonna paste that key with right click and click enter. So let me try again. You will I will create the username and password. I have created the account. I just don't want to show you the password. And then I will right click, enter. I will go up here, right click and then enter. Then I will copy the secret key, right click and then enter. And then I will use EU-West-1 and then enter. And then this format will be none. And that's it. Now, if I go to my project, Purple Team Cloud Lab main, which is where I created that project. Now I can use Terraform init to prepare Terraform to build that project for me. It should not give you any error after you created that, and it should all go well. The next step you're gonna need to do after that is to create kind of like a credential or a password to access your Linux machines when you create them. So there is, we will be using public key. We will not be using username and password. In SSH, we'll be using public key and private key, and you need to create that key. So how to create them? All you're gonna need to do is to go to your AWS console and search for EC2. Once you search for EC2 and click on that, you will get all the instances that are running on your in your dashboard, and then you scroll a little bit down here and you go to key pairs. You need to create a key pair exactly named like this, EC2 key pair. So you're gonna copy that, or you're gonna basically write EC2 key pair. You're gonna click on create key pair and then EC2 underscore key underscore pair. And then you will choose .bem. This is basically used for OpenSSH and Linux SSH. This is the one we're gonna use. We're not gonna use Booty, so we're gonna use SSH. So that's the choice you need to have, and then create key pair. In this case, I will just create an example just to give you an example. But basically, you need to create it. It's case sensitive. You need to have it exactly like this: EC2 underscore key underscore pair, and that's it. I'm just adding under test just because I have created this key pair before already. Then create key pair. Once you do that, it's gonna create this key pair and gonna create a file for you. So you're gonna take that file and you need to copy that file to a specific path. You're going to need to go to your user folder, which is, let's say, C users, and then slash, and then Amr Thabit, that's in my case, but in your case will be the user that you are using. And then either create if there is not, or go to the folder .ssh. In many cases, it wouldn't be a folder like that. You need to create that folder. It's .ssh, not just ssh, it's .ssh. You go there and you need to paste your key pair file up here and rename that file with the extension to id_rsa. I have already done that, so that will not happen, but that is basically what you need to do. So you will end up with a file called id_rsa, which is basically your .pem type of file. So that is your second step. So you created your third step. So you created the user, you set it in AWS configure, and the third thing you're gonna do is to create this EC2 key pair and put it inside the .ssh folder. Now what you're going to do is, now it's very simple from here. You're gonna write Terraform plan to see what are the machines going to be built. In this case, it's going to give you all the different things it's gonna build, and then after that you're going to use, so basically it's going to create 16 different resources, and it's going to give you 4 different IPs to use. So it's going to create the virtual private cloud, the blue team subnet, the attacker subnet, and the AD Lab subnet. This is the subnets that includes all the virtual machines, and then gonna create all the connection to them to the root table so they can all access the internet. And this is the root table, this is the internet gateway, all of this information. And as well, going to create all the security groups that includes all the allowed ports, all the allowed or not allowed ports. So here, for example, here's some allowed ports and the range that this port is allowed. So this is the kind of the firewall rules. I've created all these security groups or firewall rules inside the Terraform code, and this is basically, you're gonna build them. You're gonna set these settings on the machine to make sure that it's not open completely to public. It's basically limited to specific things, and there are basically a lot of specific ports that are open for some limits internally, or open to the public, and so on. And then you're gonna build all the machines. So you're gonna build the Red Team Caldera, which is the machine that will be used by the attacker. It's T2 Micro. It uses the EC2 key pair we just created to access. This will be the private key and the public key that you're gonna use to access this machine. And as well, that it will be its own private IP. So it will be 192.168.30.100. And this is just some information and some more data about that as well. And then there will be the blue team machine, the same thing. It's gonna be using it's a large machine, so it's over 8 GB of RAM. It has here the EC2 key pair as well, and it has 192.168.20.100. Just be aware though that this will be consuming from your money, so it's not free. This machine is not free, but it's gonna pay you you're gonna pay very little for it. But at the same time, make sure that after you finish using the lab, you terminate the lab, or you pause this machine when you don't want to use it. So that machine, just be aware though that it wouldn't be absolutely free. The other machines will be. So the third machine will be the domain controller, or the Windows 10, and basically it's T2 Micro EC2 key pair as well, but we will not be using that because it's a Windows. We will not be using SSH. We'll be using remote desktop, and as well it will be the IP 192.168.10.110, and the last will be the original machine, which will be 10.100. So these are all the machines. To basically apply all of that, to basically build all of this, you need to use Terraform apply -auto -approve, and it will build all of that for you. So now this is the building part. The last thing I'm gonna show you before we're gonna connect to these machines and do all the crazy stuff, I'm gonna show you how this code looks like step by step. So this is our project right here, and this project contains 2 main modules. One is basically a module to build the whole Active Directory, all the machines, and one module to build the whole network, which is up here. So let me explain everything a little bit step by step. So this is Terraform language. All the files are TF, and Terraform uses a language that is a little bit close to JSON files. This brackets a lot to set arguments and variables. And the first thing I'm gonna say that this is a Terraform, and this Terraform required to use AWS. So these are required providers. It uses AWS, and the AWS should be in a version that's higher than that. So this provider is basically a kind of a plugin to Terraform that it downloads to make sure that it's able to use AWS. And then we say that in this provider, we want to use the region EU.West.1. If you want to use another region, this is Ireland basically, which is where I live. If you want to use another region, just change that one into the region you want. Let's say US East-1, for example. And then we have, as we said, two main modules, the AD networks, which include in ./networks, which you're going to see right now, and the second one is the machines, or in the folder machines, which includes all the machines we're going to build. Let's look into them before we continue up here. So inside the networks, there are three main files. The main, which includes all the code. There is the output that's gonna be output from out of this module that you're gonna use again, like it's kind of a black box. Think about it. You have some magic happening there. There is some input which is saved inside variables. This is the input that will go into that box. I want this list of IPs, I want this number of machines, I want this and this and that. And then there is the outputs, which will be all the IPs, all the public IPs that have been created, the ID for different resources being created. This is the output out of that module. So that's basically our box. Our variables will be kind of a variable called environment. This is just for knowing if you want to set it as production, development. It doesn't really affect anything related to AWS. It's just being written beside the name of the machine. So it's kind of an additional value up here. There is something called CIDR prefix, which basically, if you want to put it 192.168 or 172 point something, this is a default value. So this value might not be the one that's being used inside the program. If we go to our main, we see that we set this one to 192.168 and this environment variable to lab. So we can reset these values. You can set whatever the type of private IP you want to set for all your subnet. Make sure it's a private IP. So this is the input. What is the output? Well, we output the virtual private cloud, which is the private cloud, the private company we have created. We output its ID, the subnet we are using, the main subnet. This is the subnet for the AD Lab machine. And we have the blue team subnet, the attacker subnet. This is the information about this subnets, and as well the prefix for, or the attack, the AD Lab, which is the Active Directory lab, the two machines, what is their subnet, basically IP, which is 192.168.10, for example. This will be 0.20 and this will be 0.30. So let's look at the network itself. So in the network, we create, we say that we want to create a resource. This is how Terraform works. We need to create a resource, and this resource is a virtual private cloud from AWS, and we name it that name, and this is all the arguments it takes. Of course, this is not a complete Terraform course, so I'm not like really going so deep, but I'm showing you just an example how that works. So basically, we're gonna use the block of 192.168.0.0 and then /16. That means it will be taking IPs in that 2 zeros up here. And then we'll create another internet gateway. We'll call it AD Lab gateway, and it will be connected to this private virtual private cloud. So this is the internet gateway that will be connected to that private cloud, and then we create each subnet one by one. So this is the first one. The second one will be, second module we have is the machines. And the machines we have here, we create first our security group or our firewall rules. This is where we say the ingress means this is all the inbound traffic. We allow the port 8080, and we allow from port 8080 to 8080. It means this is the only port that's allowed, and we allow for only internally for only this private network. And then again, we allow remote procedure call, the same style, and we write down all the ports we do allow and to which range of IPs we do allow to. We do it for every single subnet. So this is for the AD Lab subnet, this one, and this is for the blue team subnet, and another one for the attacker subnet as well. So after that, we go into building our own. This is for the red team, and later on we build our instances, our machines. And here we say we want to create an instance or a virtual machine, and basically we want to create it in a specific subnet with that specific IP, with that size, with the key name EC2 key bearer. And as well we have here a way to search inside the AWS marketplace and find the Windows 10 machine we want. If we go a little bit up, you can see that we are searching inside Amazon for a Windows Server 2019 English full page, and it gives us an ID for that specific virtual machine, and we use it to build that specific one with some settings to enable. Up here we try to enable the PowerShell remoting, and with that we make sure that we set all the allow to everybody to log in, and our password, which we're going to see, is one of the variables. And if we go to variables up here, the password is lab password. This is the password for literally most of the environment up here. So we build our virtual machine, and we go through that to build every single virtual machine from there. Last thing to show you is that we have one installation command we run after. This is basically a configuration file for the blue team to build the whole Linux machine and install all the tools we want. We have like a specific process where we install PowerShell, where we install Docker, and we install Hulk, or the threat hunting Elasticsearch, and this is based all in Docker, so that's why we install Docker here, and then we start installing all the Docker images, and then we do all the installation, continued installation of different tools and different things. We also install Python 3 because on these machines they don't have Python 3, so we do that. And as well we do install the Active Directory through a PowerShell script that uses PowerShell remoting. Up here, as you can see in this execute while online, we use invoke command on a specific session, and this session is a PowerShell session. It's a remote session that we use to connect to our virtual machines that we have created and install different things, create different users. You're gonna see inside this code we create all the different users inside this machine. We set their passwords and do all of the different things related to creating an Active Directory environment. So this is basically our project in a nutshell. If you don't understand everything, you might need to dive deep either to PowerShell or in Terraform or AWS generally, but that is just the whole idea. And now, as you see, we have all the machines ready up here. We have each one of these machines with its public IP. We can now connect to these machines. If we take this one, for example, and we go to remote desktop connection, we can click on this and we can give it this IP and then connect. And here it will ask you for the password. You need to choose more choices, use a different account, and we're gonna use edlab/dedan. This is the domain admin. You can also use, if that doesn't work, you can use administrator instead. So you can use either edlab/dedan, which is the domain admin, or you can use administrator, which is the local administrator on this machine. So let's use edlab/dedan first, and then lab pass1. This is the password, and then we connect. Once we connect, that is, we can allow that. This says that this is a self-signed certification for this machine, so it's not the most safe, but for us it is safe. And we have the connection is happening here, and here we are. We are having the machine. Let's make that a little bit bigger. So this is basically our machine, and we can use it and we can do whatever we want using that machine. As well, we can connect to our own blue team machine by just taking that IP and go to our browser up here. This is our key pairs. We can go to that IP and just paste it and connect. We should go that these connections are private. You say continue, and then he will ask you for a username and password, and the username and password is Hulk, and the password is lab pass1, the same password. So lab pass1, and we are in, and we have access to Kibana. As well, we can connect this machine through SSH simply by using SSH EC2-user and then the IP of the machine. You might ask you this question for the first time, you say yes, and then you are inside the machine. You can use ls to list the directories or files, and here you have all the files. You have volatility being installed, you have some additional tools, you have Kanza, which is an incident response framework, and as well, if you want to access PowerShell, you can just use bwsh, and that will allow you to access PowerShell. The same things also happens with the red team. So if we go to the red team up here, we can connect to the red team using the exact same way. Let's exit as well from the machine, and we can use ec2-user. This is the username for basically Amazon Linux 2, the default user, and then we can use our red team IP like that. We say yes, and then we access our red team machine, and inside red team machine we have the username and password for the red team for the Caldera, and this is included inside temp in a file called password. You can even do that, and we'll see the exact username and password. It's a very, very long password, but the username is always red. So if we go to, first let's take the IP, and we go to that IP up here, and port 8888. This is the default Caldera IP. We can take the username red and the password, basically our new password, as you see up here, and paste and log in, and now we are inside Caldera. So this is for this video. In the next part of this video, in the next video, or the next part of this series, we're gonna cover more in-depth Caldera, Kanza, and how we can use this framework to actually simulate an attack and look at this attack from the Elasticsearch, from investigating it deeper with Kanza, with Cape, with volatility, with all of these different things, and as well how we can use our attacking machine to attack this Active Directory. If you like this video and you want to support, if you want to see the next video, please click like on this video and subscribe to the channel so you can get all the news about the next videos. That's it, and I'll see you in the next video. Bye bye.